This conference will now be recorded.
Here the agenda for today's session. Here we are going to start with the fundamentals of what is big data. So, and then we are going to discuss about how big data differs from this traditional RDBMS. So here we will be dealing with the key features around the 6+ features associated with architecture, infra architecture, database architecture, and core volume velocity in this perspective. And followed with we are going to discuss about this architectural perspective of Hadoop, a framework which is used for storing and processing big data. And we are going to discuss about these core components of Hadoop in terms of architecture. We have Hadoop daemons. We are going to discuss about these Hadoop daemons and its functionalities. This is the agenda for today's session. So here, I will share you the curriculum here. Once the session has been over, I have tracked the curriculum. So this is the architect level curriculum that we are having. Okay, I will share to you. Here only one thing here is instead of this MapReduce basics, what I am planning to do here is I am going to add a current thing that is one of the most wide sought with respect to this big data has been concerned. PySpark for your understanding. So this is a MapReduce is a programming model which we used in Hadoop. So here now we have Apache Spark. So enhanced version of Hadoop framework. You can, in a layman point of view, you can start off like Apache. Hadoop is having certain limitations. Those limitations has been overcome in Apache Spark. Once again, it is a framework developed by Apache Open Source Foundation, distributed data storage and data processing framework. But it has a great difference in terms of performance compared to that of Hadoop. In the way it able to perform an activity almost 1050 times greater than that of Hadoop. So here we will be including apart this model 3, we will be including the following content. Okay, here we will be including to this Apache Spark and Spark operations and how to do a MapReduce using Spark. This content resilient streaming Spark SQL graphics, it is purely Spark developer content. Here we will be dealing with this first part, how to perform a MapReduce with the Apache Spark using Python as its programming language. Okay, so this is the only addition that we will be going up with the following curriculum. So today's discussion is going to be with big data, cloud computing, and virtualization, how it is closely interrelated with each other. And we are going to compare Hadoop with the traditional RDBMS in terms of opposite characteristics. And here we are going to discuss about overview of this Hadoop framework. What is Hadoop and what are the core components with respect to name node, secondary name node, data node, and so on and so on. So this is the agenda for today's session. Let me first start with what is big data. Here, big data. So can we have some interaction so that I need to aware of to which extent that you know, then where I need to start with, what are all the things that I need to deliver, then only I can make an understanding. Okay, can we have some interaction? Babu,
Yeah, sure.
yes.
Yeah, sure.
Okay, in terms of your perspective, what is big data? Any answer?
It's a huge data volume.
Exactly, perfect. Huge data volume, correct. Then
Yes.
yeah.
Normally in RDBMS, we are dealing with Teradata. It is more than that.
And
Yeah, that is huge volume. And then in terms of minimum of Teradata, terabytes. Okay, Teradata is a data appliances. Here we call this as a terabyte in terms of volume.
Right. Terabyte.
Yeah. Yes. Okay.
and
Yes,
I
please.
think there is no structure in this big data. They like RDBMS.
Yeah. So it is a structureless. Okay. So this is one of the key features associated with this NoSQL database. In the big data, we have a NoSQL database by name Hadoop. Sorry, HBase, MongoDB, Cassandra. It's structureless, very good. Okay, now let us start with that. So here Big data is a generic term similar to that of RDBMS. What is RDBMS? It is a relational database management system which is used for storing and which is used for processing data. Okay, that is the main intention. So here, similar to that, big data is a generic term. Okay, so here, what is Hadoop? Hadoop is a tool. With respect to RDBMS, we have tools like Oracle, we have tools like MySQL, SQL Server. So these are all databases. These are all database tools which using which we can store and we can do processing. So similarly, big data is a generic term which represents in a layman point of view today's digital information. So today everywhere we have computer. So we have highly intelligent computer. We need to, everything has been automated. So we need to store and we need to process a huge volume of data in terms of terabyte, in terms of petabyte, in terms of gigabyte, etc., etc. Here, big data is a generic term which is used for representing today's digital data. And similar to that of Oracle, MySQL, Hadoop is a tool. You can call it as a framework. A framework is a collection of components which facilitates for storing and processing what we call as big data. Okay. So then what is big data? How you can define a big data? Big data can be defined in the following manner. So we can define big data in the following manner. So it is a big data is any data which is beyond the storage and processing, beyond the storage and processing capability of the traditional RDBMS. Storage and processing capability of your traditional RDBMS. What is the architecture currently followed by RDBMS? It is a centralized single server database architecture. Okay, this is the architecture for currently followed by RDBMS. You have data stored on a server, you have your database on a machine. We call this machine as a server, which is nothing but your backend. And how the user can interact with this database. For that, the user need an interface. Okay, the user make use of a client. Here, the software we use is called as a front-end tools. The user will interact with the database using this front end. This is the architecture. Here, it is a single server. So, can you please mute yourself? I am getting some disturbances. Yeah, thank you. Here, this is a single server, centralized database architecture. What is a centralized? Here, centralized means the data has been stored on a central location, and you have multiple clients. Each and every client can make a connection to this database, and you can issue the query, and query got processed, and result will be written back to the client. So you can't store data beyond this single server. For example, assume that here the hard disk capacity is 5 dB. You want to store data of 10 dB instance, you can't have another server to split the 5 dB and 5 dB data here in centralized. Here the data will be on a single server only. You can have a data on another server, but this data is replicated. It is a replica of the original server. That alone is possible. You call this as a primary and you call this as a standby. Okay, you call this as a standby. So in case of the primary fails, the user's request will be redirected. That is possible. You can replicate, but in terms of here, the data couldn't be equally stored across these two servers. Okay, so this is the way by which this centralized architecture will store data. So here, the definition for big data: any data. Any data means what? So it may be a structured data, which may be a semi-structured data, which may be a unstructured data. With respect to data has been concerned, so we have structured data, semi-structured data, and unstructured data. So out of today's digital world, so only 20% of data that we are currently handling is structured data. The remaining 80% of data that we are handling is either a semi-structured data or a unstructured data. Then if that is the case, what is structured data and what is semi-structured and unstructured data? The traditional RDBMS stores data in forms of tables. Here the table is nothing but a collection, for example, employee number, employee name, okay, salary like information. It is a collection of row and column value. I have employee number 1, employee name Ram, salary 9,000. I have employee name 2, employee name Babu, salary 10,000. And any value can be accessible by specifying the row column interaction. All the records will have this equal value. If salary is not found, then there will be a null value. Okay, so all the rows will have all the values for column. If the column value is missing, it is replaced with a null value. So this is an example of structured data stored in RDBMS. What is semi-structure? Semi-structure, it may have some partial structure, like your email, your XML files, okay? So your documents, these are all coming under semi-structured data. And what is unstructured data? Your images, your audio, your video, okay? So these are all coming under unstructured data. Today's digital data, almost 80% is coming under either a semi-structured or unstructured. Only 20% of data today we are handling with a structured data. Okay, whereas your RDBMS, traditional RDBMS, Oracle, MySQL, handle only the structured data. Now there may be some extension here. So here using which you can integrate some third-party tools to handle semi-structured and structured. But here the architecture of RDBMS is single central server, and here you can't able to store data in terms of terabytes and petabytes in this single central server. And to your RDBMS is capable of handling only structured data. It couldn't have a mechanism to handle semi-structured and unstructured data in an effective manner. So these are all some limitations associated with current RDBMS. These limitations can be overcome using a tool called Hadoop that we will discuss. Now you know what is big data. Okay, these are data which may be a structure, semi-structure, and structure, which is beyond the storage processing capability of a single centralized server database architecture. This is the architecture currently followed by RDBMS and possessing the following 4 key characteristics: volume, velocity, variety, and veracity. So these are all the veracity. These are all the 4 key characteristics which makes data as a big data. So here out of which you guys have notified volume. So it is of huge volume in size in terms of terabyte, petabyte, zettabyte, etc., etc. That is one of the key characteristics. Apart from that, the big data need to possess the following characteristics: the velocity, the variety, and veracity that we will discuss. Okay, is it now making sense what is big data and what is Hadoop? Any questions with respect to this? Please let me know.
What is the second one, fourth one? Velocity and
Veracity. Reliable. How reliable? We will discuss. No issue. We will discuss.
okay.
Okay. So now this is what we call as big data, and then this is the difference. Now we are going to discuss about the differences between a big data and a normal data, which that we make use of RDBMS for storage and processing. Okay. Okay. So here, the traditional RDBMS is a centralized database architecture. We call this a single server centralized database architecture. Okay. So here, imagine the hard disk capacity is assumed to be 5 TB. You want to store 10 TB of data. How you can store if it is a RDBMS? This is your RDBMS architecture. So being you can't able to accommodate, that is it is assumed that the maximum capacity of hard disk that can be attached with this server is 5 TB. If you want to store 10 TB, here there is a solution by name. You go for a box like a NAS box or a sandbox. Okay, these are all storage boxes. NAS stands for network attached storage. Network attached storage. Here SAN stands for storage area network. The intention is same. Both is used for storing huge volumes of data in a separate manner. Storage area network. You might have heard about this EMC and NetApps. Okay. So Brocade. These are all companies which manufactures the storage box. So if you don't have a sense of storage box, I will share to you. So here it is entity EMC storage box. So here these are all you have huge collections of these are all hard disks. These are all servers. These are all only the racks containing hard disk only. You have tons and tons of hard disk. So this is a storage box. You can find okay each box can accommodate 1,000, 2,000 hard disk like this. Okay, it is all are hard disks. Okay, what is the purpose of going for that? You have data stored here and your application may be running on your server, and here you can make use of here this is your application. Assume that here your application, this is your server where your application is running. So this is the box where you can have all your data. The box can be of size 10 TB, 50 TB, 100 TB like. So you have can store the data in terms of terabytes. Here whenever you need data, the data need to be bring into the server where your application is running. It got processed and the result will be returned back. If the volume of data transmission is in megabyte, if it's in gigabyte, okay, that sounds good. Okay, you can able to transfer very fast. So let me imagine you have a film of 3 GB of film. Let me imagine 3 to 4 GB of film. If you want to copy in your pen drive, it took not less than 5 minutes to copy from your laptop. Imagine for storing 3 TB of data, how much of duration? So you have data stored here, you want to transfer 3 TB of data into the server instance, how much of time that you need? 3 GB needs 5 minutes, 3 TB, which is more or less equivalent to 3000 gigabytes, which needs 5000 minutes. For transferring, if it divided by 60, 8 are 48, okay, almost how much? 80 hours it needs to transfer. Okay, so here is it accessible? It is acceptable? It is not at all acceptable. The solution is supports if you transfer megabyte and gigabyte of data, and that too in terms of minutes and hours. Okay, here the so we couldn't accommodate this solution of having your data in a storage box and running your application for Hadoop. Okay, this supports this works fine for your RDBMS. Am I making sense what I am trying to convey? Okay, in RDBMS you can't store data beyond a single server. Okay, so here that is the limitation because data is stored in a single server. You can't store beyond its capacity. Whereas here, big data is one which possesses the following key 4 characteristics. One in terms of volume. What is volume? Volume represents the amount of data that has been stored and processed. The amount of data. Here, second one, the velocity is the second characteristic. It represents the rate at which the data has been generated. The rate of generation, rate at which data is generated. And third characteristics is variety. As we already discussed with respect to variety, we have structured data, we have semi-structured data, and we have unstructured data. All the three will form a big data. And fourth one is veracity. How far the data is reliable, reliability of our data. Okay, so here, if you take in consideration these 4 characteristics, we can differentiate between RDBMS versus big
Hey,
data.
can you say about the third one?
Yeah, which one? Variety.
Third one. Variety, yeah.
Yeah, we have just now discussed structured data means in the data that we are storing in your traditional RDBMS in forms of rows and columns. So you have a table employee. The table employee contains the records like employee number, employee name, okay, salary. Here
Oh,
it
okay,
has,
okay. I got it because just a few moment I lost a voice. Okay, so
yeah,
SD means
okay.
is
Structured
structured
data.
data, semi-structured data, unstructured. Okay, fine.
Unstructured.
Thank you.
Unstructured means your audio files, your video files, your images, so on. They are
Got you.
unstructured.
Got
Okay.
you. Got you.
Yeah, semi-structured means your email, your X. They may have some format, but it is not a fully structured one. Okay, it is not a fully unstructured one. They may have some partial structures. XML, email, your documents are coming under semi-structured. Okay, if you take into consideration the first factor volume, RDBMS, the amount of data that you need to store and process in RDBMS is in terms of megabytes, okay, gigabytes, and some few terabytes. That is the maximum storage level. Whereas big data, it starts with terabyte, petabyte, zettabyte, etc. etc. For example, if you take today the social networking site Facebook, per day Facebook is generating 500 terabytes. If you take into consideration Twitter per day is generating around 250 terabytes of this. Okay, anything. If you want to find out this gold price, so you want to take care of not less than 10 TB of data to 100 TB of data to analysis to decide this gold price. Okay, anything, any application, whether banking, insurance, portfolio. So if you want to find out this temperature, minimum and maximum temperature. Here, for example, what is the minimum temperature, maximum temperature in India today? You need to crawl data across lakhs of sensors that has been incorporated, which gives 24 hours of data, and then this data need to be analyzed to find out the minimum and maximum. You need to analyze not less than 100 to 150 TBs of data per day that is generated by these sensors to find out the minimum and maximum. So any application, if you consider with respect to big data, the amount of data generated will be minimum in terms of terabytes. That's the one of the most key characteristics which differentiates big data from a normal data. Is these characteristics alone can define that there is a big data? No. Apart from that, we have these characteristics also will have its own part of influence in deciding a data is a big data or not. Velocity, it represents the rate at which the data is generated. So imagine there is a web server, normal web server. So people are accessing the web server. Okay, on normal days, let me make it as Amazon e-commerce web server. Okay, so Amazon normal e-commerce web server. A normal day, let me assume that at a maximum 1,000 people are accessing. Amazon is announcing a flash sale, a 50 percentage offer sale on 10th, 11th, and 12th of March. And to the offer is from 10 a.m. to 12 noon, 2 hours offer sale. So if that is the case, how much of request that will pour into this Amazon web server? It will be in terms of lakhs and lakhs. Okay. So here in this case, the amount of request that is approaching this web server has been defined as the rate with the data is generated. Here in terms of big data, here you can consider this is the example. Here in terms of the velocity, in terms of first velocity. Here in RDBMS, it is in terms of megabytes of data per hour. The rate at which the transfer is megabyte minimum and normal. Whereas big data is one where it has a gigabyte per hour, terabyte per hour, up to terabyte of data generation per hour. That is velocity. Okay, and third one is variety. Here your RDBMS support only structured data, whereas the big data is one which is maybe a structured, semi-structured or unstructured data. And fourth one is veracity. How far your data is reliable. Imagine you have a table employee number is declared as an integer. Is it possible to give a E1, a varchar? It won't permit. Also because at the time of entering the data, it will validate with respect to the data structure. And the employee number is expecting an integer value, but if you here specify a varchar, it won't accept that. So similarly, you can't store a null value if it is defined as a not null. So while inputting the data need to be a clear data. The data need to be pre-processed and you need to input the data. Okay, so whereas in case of this big data, since the data is crawled from social networking sites, since the data is crawled from some sensors, the real world entities, you couldn't assure a clear data. The data may suffer from some anomalies. It may have some missing values. It may have some irrelevant informations. It may have some inconsistencies. There may be a duplications. So these are all the anomalies associated with big data. Here, your system, which is going to store and process the big data, should be able to accommodate these anomalies. That is here refers to veracity. And data is not a pre-processed one. When the data comes with different issues in your system, here the tool that we are going to make use of Hadoop will tackle with these issues. These are all the basic core characteristics which differentiates big data with normal RDBMS. Yes, is it making sense? Any
Yeah.
doubt with respect to discussion, please let me know if you have. Shall I proceed further?
Yeah, I'm okay.
Okay.
Yes, I'm okay.
Now you know what is the limitation of RDBMS. Okay, why you couldn't store data in terms of terabytes and petabytes, being it is a single server centralized, and we have a discussion of differences between RDBMS and big data. Okay, let me proceed further now. So here we are going to discuss about these key characteristics, the differences between your RDBMS and your big data. So here we are going to discuss about Hadoop. Okay, so the one is the infrastructure architecture.
Hey, 1 minute before starting, so here, right now, I understand everything on big data. So, what is this Hadoop? Hadoop is the name of big
No,
data, or is it
Hadoop is the name of the tool. So as I told, RDBMS means Relational Database Management System. It is a generic term.
okay?
Similarly,
Got you.
big data is a generic term. Then what are
So,
all the tools, databases that you use? You use Oracle, you use MySQL, you use SQL Server, is it?
okay.
Have you heard about these tools?
Got you. Yeah. So, how
Fine,
what are
Raman. What are the example of tools for this big data apart from Hadoop? Give me some other examples.
Yeah. Hadoop is a framework. Under Hadoop, we have several tools. Like we have data processing tools like that we will discuss. We have Hive, we have Pig. These are all data processing tools. For data storage, we have HBase, we have HDFS, we have MongoDB,
no,
and
similar like Hadoop? Any other technology
Yes,
is available for big data?
yes. Some other
Hadoop
framework.
distributions. Okay, so what is a Linux? Linux is a open source. Okay, so from Linux we have several distributions like we have Ubuntu. Okay, we have a CentOS. We have
We
a
can say
Red
like
Hat.
fill up
Okay,
flavors.
they are all similarly. We have Hadoop. Then Hadoop is a open source. It was developed by Apache Open Source Foundation. Here, several companies downloaded and they had their own distributions. Like we have Cloudera, we have Hortonworks, we have MapR, we have EMR, Elastic MapReduce, we have Big Insights. They are all distributions. They are all Hadoop distributions. EMR is Amazon Hadoop distributions. Big Insights is Microsoft distribution. Okay. So under Hadoop, Hadoop is a framework. It is a combination of several tools. We have Hive, Pig, HBase, HDFS, Mongo, Scoop, Flume, Niffy, zookeeper, okay, etc., etc. These are all the tools. Each and every tool serves for a certain purpose. Is it clear? Now, the enhancement of Hadoop, we have Spark. Okay, you can consider Spark as the advanced level of Hadoop. We call this as in-memory data storage and data processing framework. So we will be dealing with this Spark also. Do you have anything in your mind? Please let me know. I will clarify. If you have anything that has been taught to you, these are all Hadoop tools, please let me know. Yeah?
Okay.
So we will be dealing with all such tools. So if you take into this curriculum, you can find we will be dealing with these all such tools like HDFS. Okay, now you have this programming model map reduce, setting up this Hadoop cluster using different combinations, and then how to manage this maintenance and monitoring and troubleshooting these clusters, resource management of clusters. These are all Hadoop ecosystems, so Flume, Scoop, Kafka, Peak, Hive, HBase, MongoDB, Zookeeper, Apache Spark. Okay, each and everything will have our own discussion with a live example. Okay, so apart from that, we also deal with Amazon Public Cloud for Hadoop administrator. For architect perspective, we are dealing with additional things. And so we deal something instead of MapReduce, we deal this. Okay, the Spark, introduction to big data and Spark, and what are all the challenges associated with big data and frameworks, how it has been overcome using Spark. Okay, so once we go on, you have a clear understanding. As of now, Hadoop is a tool. You shouldn't call it as a tool. You should call it as a framework. Here, it is a combination of above set tools. Whether you use Cloudera, Hortonworks, Map, or any distribution, you have these tools. Apart from that, Cloudera will have an additional component called Cloudera Manager, which facilitates easy management of Hadoop cluster. Similarly, Hortonworks, you can use Ambari, a tool by name Ambari. So these are all own flavors, Hortonworks flavor, Cloudera's flavor. Clear?
Yes.
Clear.
So
So
Hadoop is the
whatever,
framework, and Hive, Peak, all these are tools, right?
Tools. It is a sub tool coming under the Hadoop. I will let you know what is the usage with the overall architecture. No issue. At the end of today's session, you have a clear idea of what this is.
so Raman, in whatever we are learning in Hadoop, the all subcategories you said, right? Hive, Pig, HBase, HDFS. So all these things can be used in other technologies also, like Cloudera or Ambari, or they have a different things.
No, no, no. Almost what are all the things that is listed here? It will
Okay.
be 85 percentage will be here. What is the difference between Ubuntu and Sun? Whether it is these are all different entity or same, all are based upon the common Linux kernel. 80 percentage it will be similar. Then 20 percentage alone, each and every company may have its own feature. Is it?
Got you. Okay.
Similarly, here too, 80 to 85 percentage all are same. Why is it? Because they didn't develop their own. They taken the base
Hadoop
Hadoop
developed.
and they added some features on top of it to facilitate easy user interaction. That's all. That is the difference.
Okay. Thank you.
If you go Cloudera, you can find all the thing. If you go Hortonworks, here too you can find all the thing. On top of it, they may have some new features. That's all, as a separate entity. Clear?
Raman, are you going to share this video end of the session?
Definitely.
Thank you.
Even though I share, you just make a hint, a small hints whenever I say something regarding interview questions and core key concepts. Just make a note. That's all. It will be easy for you later study. I will share the video.
Yes, I am
All
using a notebook.
unto while doing practical, I will share you the document also along with video.
Fine,
Being,
Raman.
being there are concepts, we couldn't type it and say. So I will explain you clearly. You grasp those concepts. You store it in your mind. That's all, in your brain. Literally, you can recall it anytime. Yes. Thank you. Now this is the now we are going to discuss about the two core components with respect to this RDBMS and Hadoop. That is the architecture in terms of infra and database architecture. This is your RDBMS. This is your Hadoop. So whatever may be doubt, whatever chilly it may be, no need to worry about that. Feel free to clarify. If and only if you clarify, then you can able to attend with a peace of mind. Okay, I won't think differently. So I will think differently if you carry with your doubts. If you don't clarify, then you will be the loser. Okay, please don't hesitate. That is my humble request. Whatever chilly it may be. So RDBMS. So in terms of this infra, it is a client server architecture. RDBMS is a client server. Whereas here Hadoop is a master slave architecture. You have a server and the user will interact through the client. They may have multiple clients. Okay, you have a server. In the server only data storage and data processing takes place. Data storage and processing takes place in the server. Okay, the user will interact through this client. They issue a query. The query will be taken, it got processed, and result will be written. That is the architecture. Here it is a master slave. Some machine have been designated as masters. Some machine have been designated as slaves. Okay. Each and every machine will do certain functions. For example, here we have a computer called the name node. Here we have a computer called the secondary name node. Here we have a computer called a job tracker. Here we have computer called data nodes. Here we have computer called task trackers. Okay, they are all masters and they are all slaves. Each and every node will have its own functions. Okay, so here the name node is the entire controller of the entire cluster. It is the main controller. It will maintain all the metadata information about the cluster. If a name node downs, nothing can be done on a cluster. Your cluster will become standstill. If a name node downs, here comes the secondary name node. The secondary name node helps name node in its recovery. I am giving you a bird's view overview today. We have a separate session for each and every how to configure name node, what are all the functionalities, okay, what is the usage, everything will be taught separately in the forthcoming sessions. Now I will give you an overview. What is name node? So name node is the master. It is the main controller of the cluster. Then if name node downs, here we have another node called a secondary name node, SNN, secondary name node. So here if a name node downs, the secondary name node couldn't take the control of the cluster. Here the secondary name node helps the name node during its recovery phase. It helps the name node in letting the name node know what is the status of the cluster. Okay, so it is not a replacement to name node. Name node downs means you can't do any activity on a Hadoop cluster. And you have another computer called the job tracker. You need to configure a computer called job tracker. And here, these are all the master computers. And you have multiple data nodes. You may have more than one data nodes. Data node 1, data node 2, up to n data nodes. On each and every data node, there will be a task tracker 1, task tracker 2, okay, task tracker 3. Task tracker is a daemon, a background process running on the data nodes. Okay, these are all masters and these are all called slaves. So this is the architecture. So here the data storage and data processing takes place only on the slaves. Data storage and data processing takes place only on the slaves. Whereas here in server, data storage and processing takes place on the master, that is on server, that is reverse. The node where you store data and you process data is called as data node. Here the master will be only the controller node. Okay, so the master will do some control activity. Babu, Daniel, can you please mute yourself? Thank you. In case if you have any doubt, you unmute and clarify. This togetherly called Hadoop cluster.
Before you proceed, right? Can you talk a little bit about the secondary name node? So it's you said
Raman,
it's not exactly the secondary node. When primary node goes down, the secondary node is not going to up, right? Something you was talking about secondary node. Can you give some little bit clear picture about secondary name node?
While proceeding, we have a separate sessions for that. Before going into that, I want to let you know something details. Then only it will be understandable. What activity a secondary name node will do when a name node down.
Okay.
Okay, so just a bird's view. That is the reason why I have insisted this. I am giving you a bird's overview of what is what. That's all in today's session.
Okay, right.
So you need to know what is metadata, how the name node controls all the data node. Then only I can, if I explain the functionality of secondary name node, that will be understandable to you. As of now, you just make a note. There is a server called secondary name node. Whenever name node fails, it helps the name node in return back to the normal state. That's all. This is the functionality. A layman. Yes, clear? How
clear,
secondary?
Raman.
How
I
secondary?
have a doubt, Raman.
Yeah. Yes.
See, என்ன புரியலன்னா நம்ம கிளையன்ட் சர்வர் ஆர்டிபிஎஸ் பாத்தீங்கன்னா இந்த யூனிக்
ஒரு
வேல்யூன்னு ஒன்று இருக்கும் அனுப்புங்க கம்ம
request
சீரியல் நம்பர்
இல்ல மூணு பேரும் நம்ம பாபு டேனியல் முரளி தமிழ் தானா
ஹலோ
ஆமா எல்லாரும் தமிழ் தான்.
ஏன்னா நம்ம ஒரு
sorry,
ஆள்
no issues, I'll switch out English. In RDBMS concept, when we are talking about client server, there will be some unique value. For example, if we are doing banking operations, there will be serial number, account opening purpose, 1, 2, 3, 4. But if we are coming out of client server architecture, the data is stored in different places, how the uniqueness, how the serial number will be controlled or monitored.
here.
Otherwise, is it only for the research purpose?
No.
Could you
Here,
give some practical example?
today only we have started the class.
Okay.
Today only I need to go through a tons and tons of information.
Sorry, Raman, please go ahead.
Those things will be taught during HDFS, HBase. I understand
Okay.
your
Actually, due to curiosity, I tried to understand what's the main difference between the data storage of these two RDBMS and Hadoop. That's it. Thank you. Go ahead.
It is understandable one by one. Okay. At the end, I assure each and every word is known to you with respect to Hadoop.
Go ahead, Raman.
Yeah. So here, this client server, you can't do analytics on client server. Okay, it is used for only the day-to-day data. So we will have a discussion of what is the difference between this client server versus HDFS. At that time, you have a clear understanding of what is what. It needs to support ACID property. Here there is no ACID property. Here it is need to support a script schema. It is schema less as of something told. So those things will be taught later. Only 1 hour today. Within that 1 hour.
Fine, Raman, please go ahead.
So what are all the doubts? You just make a note. At that time, I will clear you. No issue. If you are aware of the concept behind HDFS, the answer for your question will be clear. Okay, HDFS will be We'll be discussing HDFS probably on the third class.
Fine, Raman.
Okay. So now, okay, name nodes, secondary, these are all the nodes. Okay, togetherly, this is called as a Hadoop cluster. Cluster means it is a combination of several computers. Okay, so in terms of Hadoop, these are all the computers that you need to make use of it. Here, I want to ensure one thing. Here, with respect to this master, you have only one name node, only one secondary name node, only one job tracker, and you can have n number of data nodes. Then number of data nodes depends upon certain factors that we will discuss first. So this is the difference between in terms of the architecture. It is a client server for RDBMS. Now Hadoop is a master slave. We have several computers. Some computer has been designated as masters, and some computer has been designated as slaves. The purpose of slave is for storage and processing. The purpose of master node is to control all the activity. Okay. So to which this extent, if you have understanding, that is enough for today. And in the terms of database architecture, now what is the architecture wise it differs? Here RDBMS follows a centralized database, whereas your Hadoop follows, your Bigdata Hadoop follows a distributed database. So what is distributed database? Imagine you have data nodes. Okay, each data node capacity is 2 TB. Here you want to store 10 TB of data. You want to store 10 TB of data. Here in RDBMS, you need to have a server with a hard disk capacity of 10 TB, a single server. Then only you can able to accommodate all the data. Okay, this is a single server centralized database. Okay, whereas here in this case, so you want to store 10 TB means what you can do? You can have 5 data nodes. Data node 1, data node 2, data node 3, data node 4, and data node 5. Here this 10 TB has been splitted as a layman 2 TB, 2 TB each, and it will be stored partially. Okay, each data node holds 2 TB of data. So when we assume this 10 TB consists of 10 lakhs of transaction means each data node is assumed to be having 2 lakhs of transaction records. If the data is splitted and it will be stored across evenly all the data nodes. Imagine if you have 10 data nodes, here the data can be splitted into 1 TB and it can be evenly distributed across all the data nodes. It is up to the choice to decide how much data that you need to store. So this is the way by which your data is splitted and it will be distributed across multiple data nodes, which is called as a distributed database. Yes, centralized database, you have data stored only on a single machine. It won't go beyond that machine. This is called a centralized database. That is the major difference between distributed and centralized. What's the advantage of going for distributed database? Let me imagine to have a 10 TB of hard disk, which is considered to be a maximum storage capacity. Now you want to store another 5 TB of but your server's capacity it can able to accommodate only 10 TB. If you want to store 5 TB, it is not at all possible in a centralized database architecture. Here, what it is possible? So here you assume that you have 5 data nodes. Each data node is having 2 TB. If you want to store plus 5 TB, no need to worry about that. You can add 3 new data nodes: data node 6, data node 7, and data node 8. So now you have 8 data nodes. Totally it can able to accommodate 16 TB of data. Is it making sense? Here you don't need to worry about how much of data that is incoming. So here, based upon your current data's requirement, you can go up add the data nodes. The process of adding the data node into the cluster to accommodate the more data has been termed as scaling. Here there are two types of scaling. One is vertical scaling and another one is horizontal scaling. Here, what is vertical scaling? Vertical scaling means assume that you have a data node with 2 dB of capacity. You want to store 4 dB means you can add another hard disk with 2 dB. If you want to store 6 dB means you can add another hard disk with 2 dB. This is called vertical scaling. And the hard disk is attached to the same data node. Whereas the horizontal scaling means instead of this, what you will do? You will be having 3 data node each with 2 dB hard disk. Okay, therefore totally it can able to store 6 dB. So this is the difference between horizontal scaling and vertical scaling. Hadoop follows horizontal scaling. It doesn't follow a vertical scaling. What is the limitation of vertical scaling? You can't go and add the number of hard disk. Okay, here the server should have the capacity of accommodating this hard disk. You can't go and attach as of your size. Whereas in case of horizontal scaling, there is no limitation. You can go and add your additional servers. Okay, you can go and add your servers according to your current workflow. So here Hadoop follows the horizontal architecture. So these are all the ways by which your RDBMS differs from Hadoop. Yes. So how it will be splitted, who will split it, everything will be discussed in coming classes. It is the responsibility of the name node to do the activity. I will let you know with a small example how the data will come inside and how the name node will split and how it will store the data across data nodes. Now is it clear? The architecture wise different.
Raman, is it possible only one practical example for this horizontal scaling?
Practical example means if you want to crawl Twitter data, you want to do some sentiment analytics. Okay, you are going to find out who will win the election 2019. So several people post their sentiments on Twitter, Facebook, etc., etc. You want to crawl those data. Okay, here you can't able to identify how much of data that you need to store. So here, if you go for a structure like here RDBMS, you can't be put in, as I already told, RDBMS couldn't able to handle data beyond terabytes, petabytes and so on. It can handle works fine up to gigabytes and up to terabytes. Is it clear for you? Now with the assumption, you can crawl 10 dB of data, assume that you have 5 data nodes in your cluster. But the data size incoming data size increases to 14 dB, 16 dB. What you can do, according to increase, you can go and add your data. This is the live example where you can add data nodes as of your requirement to do analytics.
So you like to say we can increase the number of nodes for the years. Maybe first 2 years one DN, next 2 years another DN, like that.
Not on year. On that moment, how much of data? இப்போ நீங்க ட்விட்டர்ல எத்தனை பேர் டேட்டா போடுவாங்க அப்படின்னு உங்களால கெஸ் பண்ண முடியுமா?
ஓகே.
பண்ண முடியுமா?
கஷ்டம்.
அப்ப நீங்க எவ்வளவு டேட்டா வந்தாலும் உங்களை அகாமடேட் பண்ணும். இனிஷியலா நீங்க என்ன பண்ணிருக்கீங்க? யூ அசியூம் ஒரு 10 dB டேட்டா வரும்னு நினைச்சிட்டு ஒரு 5 நோடு கிளஸ்டர் வச்சிருக்கீங்க.
ஓகே.
திடீர்னு 20 dB வந்துச்சுன்னா என்ன பண்ண முடியும்?
ஓகே.
அப்ப நீங்க இன்னொரு 5 நோடு வேணுமா?
ஓகே.
அதை ஆட் பண்ணிக்கலாம், உடனே ஆட் பண்ணிக்கலாம். அதான் நான் சொல்ல வரேன். ஹாரிசான்டல் ஸ்கேலிங். எப்பதான் உங்களுக்கு இப்ப நீங்க 20 dB வச்சிருக்கீங்க, நீங்க திடீர்னு உங்க டேட்டா சைஸ் வந்து இப்போ 8 dB ஆயிடுச்சுன்னு வச்சுக்கோங்க. உங்களுக்கு 10 டேட்டா நோடு வேணுமா? இந்த எக்ஸாம்பிள்ல தேவையில்லை. 8 dBனா 4 டேட்டா நோடு போதும். அப்ப நீங்க அன்வான்ட் டேட்டா நோட ரிலீஸ் பண்ணிக்கலாம் கிளஸ்டர்ல இருந்து.
Some rare occasions we are doing the SAN disk in the SAN in the same way, right?
Yeah, you create a LAN and in SAN storage you are mapped the LAN to the needed thing. Here you will add a separate server, not a LAN. You will add a separate server according to your data.
Okay.
So Raman, here each data node will be considered as a considered like a RDBMS centralized server, maybe having a data node connected to storage, or each data node will be having its own storage on the box itself. How is it?
Each data node will have its own storage. You won't use Each data node is a separate physical server.
And it's not connected to storage.
No, it will have its own hard disk.
Okay.
That is distributed database. Okay. The reason behind that, so if here the data that you need to store here is terabytes and petabytes. As I initially told with an example, if for 3 GB, if you want to transfer a file of 3 GB, it took 5 minutes. If you want to transfer a file of 3 GB, can you wait for 80 hours? The example சொன்னேன் first.
Yeah. We cannot wait that much time.
Yeah, that is the problem. If you have data in storage, data need to bring here. So it will be a time consuming. Therefore, the data need to be stored only on the hard disk.
Okay.
So within first 3-4 classes, you will be cleared with everything. Okay, day one itself, it is very difficult for me to clarify all your doubts. I appreciate your curiosity. No issue. Being you are with the 10 plus, I appreciate. Okay.
Because decades together we were trained in RDBMS concept. The RDBMS is there in our blood and vein, Raman. That's a challenge.
It normally it needs to be slowly transformed. I think.
So we
Okay.
have to unwind, Daniel. We have to slowly unwind our RDBMS techniques
Definitely.
to understand this one.
As you
Right, right.
already admitted that it is running into your hearts and minds for 10-15 years. It can't be eradicated within a moment. You know one thing. So நான் வந்து okay. நான் வந்து first I am a Oracle professional தான். என்கிட்ட